I'm Matthias Niemann of PIRCHE, and I'm going to show you today how you can use your high-resolution typed solid organ transplant patients and high-resolution donors to match, for example, for the workup of a kidney transplantation. Probably it's best to jump directly on my screen. All right, so here we go. Let's go to our PIRCHE website and I will just quickly log in. Today we're going into the SOT single patient module and checking out how we can match using high resolution typing data. There are a couple of different options how to enter your data here. Like for example, you can enter all of your data manually, which would then look something like that. You can enter some data in the single allele fields here, and you get some auto-completion features if you want to have some support finding your data. Also, you can enter your NMDP multi-allele codes here, but please make sure to select a certain allele of these multi-allele code. Of course, this is quite error prone. So another option is to enter your data here using our input wizard, the field that you can see up here. And what it basically does is it extracts the data from the input string that you pasted in there. So this can be, for example, a CSV format or a GL string. Now PIRCHE thought this is a serologic typing because you're in the SOT module. So we can switch here by clicking on the DNA serologic button back to molecular typing, and then all of your input fields here got validated. So if your data is completely entered here and you made your modifications, you can export this whole input mask here as a file in case you want to apply your match at a later point or add more donors, make edits or something like that. And this saves the data on your local hard drive, so there's no data stored on our side. So another option to upload the data is to actually push the data from your NGS Typing Software tool suite onto the PIRCHE website. And the first partner who was integrating this API was actually Omixon. And here you can see the Omixon HLA TwinTyping software, and I can open here a sample for the details. You can see here the typing results of their NGS approach. You can see here 4 field results. And if you want to push all of this data now to the PIRCHE website, you can press the Send to PIRCHE button here on the top right hand corner. And this will open up a small dialog where you can select what to actually upload to PIRCHE. So in case of ambiguities, for example, you can select here a different pair of alleles. And if you're all set, you can click on the Finish button, and this will immediately open up a new browser window where you may need to enter your credentials again, and then you can select the PIRCHE module you want to use. Today we're interested in the SOT single patient module, therefore we click on that button here, and as you can see, it loaded now all the typing data from HLA Twin into our PIRCHE application. So now we only need to do the same for our donor and we're good to go. For the donors now, we can, for example, use the input wizard here to enter our typing data. We switch to molecular typing. We could add more donors by pressing the plus button, or we can copy over the patient typing in case we have a very similar typing here. Let's assume we have something like this. So now let's press the match button. All right, so as you can see, we have our PIRCHE results here in this tabular layout. We see the donors that we entered before. We could filter for certain donors, for example, and we can sort the results, for example, by PIRCHE score. Here you can see our actual PIRCHE-II value. This is 17 for the A0101 mismatch, and here this completely mismatched donor has a score of 88. Something else you can do here on this page is download these results as CSV file. This allows you to load the complete data into Excel or any other statistics software. And you can also download this form here as a PDF file in case you want to provide it to your clinicians, or you just want to have it for documentation purposes for a later point. So an important thing I want to mention here is that on the top right corner of the PIRCHE application, there is a switch for the clinical mode and the lab mode. And in the lab mode, you get features enabled that aren't yet part of any publication. So if you really want to use the latest features, switch to the lab mode. If you want to use the score for your clinical application, please make sure to switch to the clinical mode. A very interesting new feature that is available in the lab mode is, since version 3.0, that you can provide more loci as presenting and more loci as presented. If you switch to the lab mode, the navigation bar here turns pink, and we now have the option to change the number of loci to enter here. And I want to switch now to an 11 locus example and show you some more insights. So I now copy some data via the input wizard, switch to molecular typing, both for patient and donor. Now let's press the match button. So after a few seconds, we again get our result here. And as you can see, we have plenty of mismatches up here, but we entered way more loci than before, and we have a huge PIRCHE score. So now let me go into the details view. And as you can see here, we have a heat map view that presents now on the y-axis the presenting molecules, and on the x-axis you find the mismatch or presented alleles. By selecting the grouped button up here, you can even switch into a view where you see all the alleles here one by one printed onto that heat map. So this heat map actually shows you in gray the spots where no presentation is supposed to happen because no allele is given or this locus is not considered being presenting. In green you find the matched alleles that are considered as being self-peptides, therefore, so you wouldn't expect any presentation to happen here anyway. In blue you now find mismatch situations where not a single peptide is actually being presented, and this goes then on that color range here up to the pink color. This is actually capped with 15 peptides, and it shows you then that there are plenty of peptides being presented by this molecule from the molecule on the x-axis. The column sums and the row sums indicate how many peptides being presented by this molecule here. For example, the DQB0201 is presented with 69 peptides, or vice versa. If you check out the rows here, the DRB1501 is presenting 102 peptides, especially here from the DQA, DQB area, whereas the class 1 molecules are pretty low expressed on the DRB1501. And you can see we have here 23 peptides, and these are also highlighted and listed here on the right hand side of that graph. Let's switch back to the locus view, and you can see again the DR locus here is rather low in expression of the ABC derived peptides. The DQA and DQB apparently is rather strong in being presented on all loci actually. So let's scroll down a bit. There we also have, again, like in the HSCT modules, our tabular view. You can see here on the left hand side the presenting alleles. You can see here the presented alleles, so the mismatched alleles, and how many peptides actually are being predicted to be derived from that. And here you can see the actual peptide with its IC50 score. The imputation score does not apply here for high resolution results. The peptide with the lowest IC50 score here is printed in black, whereas the others, the duplicate versions, just written in gray, and you can just deactivate showing them, so it's a bit tidied up. And you can see here, because we have a huge PIRCHE score, we have plenty of presenters, we have plenty of presented molecules because we have so many mismatched alleles. So we have a huge list here of peptides. So the presentation heat map we see here is also available in the clinical mode, but in the clinical mode, of course, you do not have access to all of the presenting and presented loci like here in the lab mode, and therefore I wanted to show you the example here in the lab mode. So I mentioned this already in the last episode, that you cannot compare a score that was created with a different set of provided loci. The reason for that is that we sum up all the peptides for all the presenting and presented loci. If you do not provide DQA and DPA and DPB, then we cannot predict the presentation capabilities of those loci. And then, of course, your score will be lower than compared with a patient where you provided all that information. So please make sure only provide scores against each other where you provided the same number and the same loci. Thanks for watching. I hope you learned something in today's episode. Just let us know if you have any more questions. Just write an email to the below email address or use the contact form in the application. And see you next time.